Hi, this is Bill Punch at Michigan State University, another video in the series of videos on the topic, the practice of computing using Python, CSE 231. Today we're going to extend our range a little bit on our understanding of classes. We've talked a lot about encapsulation. Today we're going to talk about the concept of inheritance. Let's get started. So we have spent a lot of time talking about classes, and we have talked in particular a lot about the idea of encapsulation. The idea that we can hide information, share information by encapsulating it and providing methods to access it in a class. Today what we'd like to do is to move on to the second main item in object-oriented programming, which is inheritance. How do we do inheritance? Well, here's a basic fact. When we create a class, in parentheses at the end of the class we always indicate in parentheses the parent class that this class belongs to. So in this particular example, we create a class called myClass, and we say that its parent is the object class. An object in Python, with a small o, by the way, is the top level class in all of the Python elements. By parent class, we mean to say that we can create a kind of hierarchy, an arrangement of classes in a kind of pyramid. The top of the pyramid is the most general class, and as I said, object with small o is the top class in Python, the most general class. One level below object are classes that have object as a parent. myClass, which we defined above, is one such thing, and we create this implicit hierarchy by the definition of the classes. Here's an example. So if we create the myClass object, then we can create three other classes. Subclass, which is a sub of myClass, subclass 2, also a sub of myClass, and subclass, a class of subclass. And if we instantiate this, then by the implicit way that we've created the classes, we've kind of created the following arrangement of elements. We got object for free. It is Python. We created myClass. When we created subclass, we said its parent was myClass. When we created subclass 2, its parent was myClass. When we created the subclass, we said its parent was the subclass. And we create this hierarchy implicitly by the definition of our objects. And there's two ways we can read these things. You can read going up the hierarchy from specific to general, and we talk about moving to the parent or superclasses as we go up. Or we can talk about the most general object and move down the hierarchy, going to subclasses or child classes, more particular kinds of classes. So this is a general organization of classes implicit in how we said which parent belongs to each class. You should be asking yourself the following question. So what? What does this get me? So my classes are arranged in some interesting way, but how did that help us? And this really is the last in a piece of the puzzle that we call the find the method game. Remember the find the method game? What we knew so far was that every instance knows the class that it came from. It was stored in its double underline class, double underline attribute, so that when Python is asked to look for an attribute in an instance, it first looks in the instance itself and then up to the class that the instance came from. To this we now add a third element. If in fact it's not in the instance and it's not in the instance's classes, then we look up to the parent class to see if the attribute is there. So we continue searching up the hierarchy through the parent classes until one of two things happen. Either we hit object and don't find the attribute, or the first element, or I'm sorry, the first class in the hierarchy that has this attribute, we return that value, which would look something like this. First in the instance, then in the class of the instances, and then continue up the superclass, parent class, until we find the attribute. Typically, instances don't have their own local copies of a method. The methods are typically stored in the instance's class, and there's a reason for this. That means that all instances have access to the same class methods. They don't have to be instantiated locally. They share them through the class. But now what's interesting is we allow ourselves the opportunity to create subclasses and superclasses so that if we want to share in something that comes from our parent class, we don't have to re-implement the method in our class. It's a little hard to understand this, but let's just do a quick scenario. Imagine you're working for a team that's developed a graphics display, and the graphics system allows developers to draw figures, triangles, circles, so on and so forth. And you come in and they ask you to do the following. Hey, I would like you to make a new class called the labeled rectangle class. It's everything that a rectangle does, but I want to put a label on it. How would you go about this? Here's two bad ways. The first thing you could do is you could just write it from scratch. But that's a terrible idea. Somebody's already written all the stuff that would allow you to draw a rectangle. It would be great if we could use that and not have to re-implement it every time. So we don't want to do that. We could take the existing rectangle code and modify it so that we could put a label on it, but that's not a very good way to share information. Somebody's responsible for the rectangle class and its code, and it would be bad if anybody can go in and change it. That would be difficult to share changes as they were developed by a group. So the third way, the good way, is to say, look, I'm going to make a new class. I'm going to call it labeled rectangle. I'm going to make it a sub, have as a parent the rectangle class, and inherit everything that rectangle does. And only change in this new class I created those elements involved in putting the label on the drawing. That's all I need to do. Inherit everything from rectangle, all that it does and all the things that it works with, and only add those new things to the new class. This clearly isolates the things that need to be done. My changes only affect the new class. Existing classes are left unmodified, which is great. And I inherit everything that the parent classes do. I don't have to reiterate. I don't have to reproduce them. The bottom line is this. Inheritance allows a group, and this is what's hard for us to sort of feel when we're doing independent development, but allows a group of developers to share and create new code in a consistent, unified manner. Now we'll show you some examples of how that would work in the next video.